Now we are starting and discussing a lesson. Its name is motion in a straight line. This motion in a straight line is a subtopic or one of the branch in kinematics. Kinematics is a branch of physics which deals with the motion of bodies, and it is not dealing with the cause behind it. Means, suppose if this is the body, initially all bodies will be in rest. This is a well-known law of the Newton's. This is in the rest. If it is want to move forward, unexpected motion is not possible. Any external force should be applied on the body. If the external force is not applied on the body, then it won't move. Means if you want to move a body further, there is a need of external force should be applied. But in motion in a straight line are nothing but the kinematics chapter or kinematics dealing, we are not discussing the force behind the motion of the body. This force is the reason behind the motion. In kinematics chapter or in this chapter, we are not dealing with the equations and purpose of the equations of force. But in dynamics, we are dealing with the force because Newton has explained in a great way to understand the force in 3 different forms of the laws. Those are universally called as Newton's laws of motion. But in this chapter, we are not dealing with the Newton's laws of motion, but we are dealing with the positions of the motion and the time taken for the motion, speed, velocity, acceleration, graphical representation of all these physical quantities. So, kinematics is a branch of physics which deals with the motion of bodies but not the reason behind it. So, this motion in a straight line is also called as rectilinear motion. Rectilinear means straight line. So, or straight line motion. So, we are not discussing the motion of the bodies which are in the curved paths, zigzag paths or circular paths, not like that. But their trajectory may be in the straight line, but we are not dealing with this rounding motion. We are simply dealing with the straight line motion. So, this is also called rectilinear motion. So, in this way, we will deal in this lesson. So, there are many physical quantities which are useful or which are essential to describe the motion of a body in straight line. We are going to discuss all these things one by one. Now, what is a motion of the body? If an observer, how he can confirm that the body is in motion? So, there are a lot of things to observe. So, it will be like this. This is the position of the body initially. Let us say the position is A. At A, one observer is there. Observer means maybe a passenger, the one who is observing the things. In his view, means in the observer's view, if the body is continuously changing its position as the time leads on, that is said to be motion of the body. So, if a body continuously changes its position with respect to surroundings, then the body is in motion. Then the body is in motion. That means if you want to find whether the body is in motion or in rest, this with respect to surroundings is very, very important. That means if I am the passenger, if I am the observer who is observing a body, whether it is continuously keep on changing its position, then you can think that the body is in motion. If it is not, we can say that the body is in rest. Means the one who is observing is called surrounding. If the body is not at all changing its position or fixed to a particular point for long interval time with respect to an observer or surroundings, then it is called rest position of the body. That means if a body not changing its position with respect to surroundings, then it is called rest position. Means there is no change in the position of the body for a long interval of time or for a great interval of time, so the body was in the same place. That's why we can say the body is executing the rest position. If it is continuously changing, then we can say it is executing the motion. Whether it is rest in motion, how we can say? We can say with respect to an observer. In scientific words, that observer is also called as surroundings. The next point we should discuss in this lesson is distance. From this distance, we are discussing about the essential points which is useful to describe the motion of a body. The first one is distance. So, how we can define the distance of the body, or distance covered by the body? Let us say this is the initial position of the body at A. It is a straight line, that's why the body was moved towards straight and reached a point called B. This B is called final position. So where IP is initial position, FP is final position. See, these 2 points are collinear to each other, means these 2 points are fixed along a straight line on either ends of a straight line path. But if this is the original route, at any point in the middle, if there is a problem occurred, then up to here the body will come, from here onwards it will take the diversion to reach B. Of course, this path is also closed to some reason, then from here it will reach B in any other path. Why these examples are needed? How these are related to distance? Yes, distance is defined like this. The actual path length followed by the body, or the actual path length covered by the body irrespective of direction, is called distance covered by the body. Means distance is the actual path length, whatever may be the shape of the path, whether it is a straight line, whether it is a curved line, or whether it is a zigzag path like this. Whatever may be the path, whatever may be the shape of the path, we should not consider the directions in the change in the path. We should consider how much length it is traveling to reach the destination. So, distance is defined like this: the actual path length covered or followed by the body. Irrespective of direction. is called distance covered by the body. It is in English alphabets, maybe it is represented with S or R or X, whatever it may be, it is our convenience. Because in gravitation, we used to discuss the distance between the two masses is the small r. In some textbook it is x. So whatever maybe it is our convenience. Everything is representing the same distance. So in the definition itself, we can say that it is irrespective of direction. Means if the path is changing the direction continuously, yes, don't think about the change in that. We should think about the total length from the initial position to final position. Yes, here it is alternative paths. Sometimes these alternative paths may be like this also. We know that while we are traveling to the destination places, whether the clear routes are not there, then we should think about the alternative routes, whether it is zigzag or also. We used to redeem that. So what we can say is the distance is like this. So what is the physical nature of the distance? Distance is a scalar quantity. It is a scalar quantity. Scalar means which has the magnitude not dependent on direction. So scalar quantity means has the magnitude but independent of direction. You can say independent of direction or not having the direction also. This is a brief history, a brief explanation about the distance. The next physical quantity to describe the motion is displacement. Everyone think that distance and displacement are seems to be same pronouncement, so that's why these two are same, but not. Distance and displacement both are different to each other. Only in few cases, not only few cases, only in one case, the magnitude of distance and displacement are same. Before going to discuss about that, what is the nature of this displacement? How can we define the displacement covered by the body? It is like this. In the previous example, if you took the previous example, initial position is A, final position is B. This straight line is the actual path to follow the body. Yes, if these 2 points are joined together on a straight line on either ends, sometimes one point will be like this and another point will be like this and another point will be like this. If this is the case, a person wants to move from A to B, again from B to C. If it is from A to B and B to C, then what we can understand is he has to move from A to B, then he took the diversion from B to C. Yes, it took a long length simply. But what is the shortcut from A to C? Yes, it is a direct route. Let us suppose this is some 6 meters, this is some 8 meters. This will not be in between the 6 and 8. So how it will be look like? This AB plus BC, it is distance. But if you draw a straight line directly from A to C, this is shortcut. But the people are always chooses the shortcut to reach a long destination. If it is a perfect shortcut, they will choose that only because it reduces the time of journey, it reduces the work to do the journey. So that's why always the human beings prefer the shortcut to reach a destination. So this shortcut in scientific words is called displacement. So what is displacement? The physical definition of the displacement is the shortest distance between initial position to final position with respect to time. So time is very, very important. Means while we are measuring the distance or displacement, time difference is automatically there, because if it is a short distance, it will take short time interval. If it is a long distance, it will take a long time interval. So the shortest distance between the initial position to final position is called displacement of the body. So displacement is always a shortcut to reach the final destination. Only in the straight line motion or rectilinear motion, magnitude of distance is equal to magnitude of displacement. In rectilinear motion, magnitude of displacement is equal to magnitude of distance. Now we will see the clear differences between the distance and displacement with the help of mathematical proofs. So displacement is a vector. A vector physical quantity means both has magnitude as well as direction. As well as direction. This displacement is how different to distance. We will see some examples, then you can understand. Let us take a body. One example, first example. It was travelled from A to D in a straight line path. Meanwhile, 2 points are there. We can compare this one like a bus is traveling from one point to another point by crossing all the halts. This B and C are almost similar to the halting points of the bus. So let us suppose from position A to position D, the body has covered 300 meters, let us suppose. So we can say A to B is 100 meters, B to C is 100 meters, C to D is 100 meters. So we are taking round figures for our easy calculation. So what is the distance travelled by the body? Distance travelled by the body is equal to AB plus BC plus CD. Yes, 100 plus 100 plus 100 meters is equal to 300 meters. Because we are keep on adding the distances or lengths covered by the body in the given prescribed path. What about the displacement? Displacement, how can you define the displacement? Shortcut. But in a straight line there is no shortcut. But we can say landmark at final position minus landmark at initial position. So this is the landmark from A to B, B to C, C to D. A is the initial position. D is the final position. Automatically, if A is at 0th mark, D will be at 300th mark. So the landmark at final position is 300. Landmark at initial position is 0. So automatically the value is 300 meters. From this example, we can understand that if a body keep on moving in a rectilinear path or straight line motion, then in straight line or unidirection, then magnitude of distance and displacement are same. This is called unidirection. Once the direction changes from D to another way, then this example will give the another result. So only in the straight line motion or unidirectional motion, distance magnitude is equal to displacement magnitude. The next example, the same diagram we are taking, A to B, B to C, C to D. As we know, the distance from A to D is 300 meters. Means, yes, this is 100, this is 100, this is 100. AB is equal to BC is equal to CD is equal to 100 meters. So what is the difference between the distance and displacement? Let us suppose a body has traveled from A to D by crossing the points B and C. From here onwards, it was moved back to C. Means it has reached the destination D. After finishing the work, it was moved to C in the reverse direction. In this case, we should find out the distance and displacement. So we know that distance is equal to, what is the actual path then followed by the body? A to D first, then from D to C. So A to D, from D to C. We know that AD is equal to 300. The distance from D to C is 100. This is 400 meters. But try to find out the displacement for the same situation. So what is the meaning of displacement? Shortcut. Anyway, the body was initially traveled from A to D, then it reached to C from D. Shortcut means no need to see the total coverage. Body has started A, anyway it was ended its journey at C. So what is the shortcut from A to C? AB plus BC. 100 plus 100 is equal to 200 meters. In another way, we can prove the same. Yes, displacement is equal to, yes, initially AD is the path. Once the direction changes, because displacement is a vector physical quantity, once it changes the direction of motion, we should represent with the opposite sign in nature. So that's why AD plus of minus DC. Because AD and DC are opposite to each other. So AD 300 plus minus, what is DC? 100. So it is 300 minus 100, 200 meters. Now we got the difference. Distance is the actual coverage of the body in any path. Displacement, shortcut of the body from initial position to final position. We'll see one more example to find the differences. This is one position. This is the another position exactly in the opposite corner, like a room. 3 persons have started motion from this position A to reach this corner point. Those 3 choose the 3 different paths. One choose this path, Another one chooses this path. Third one chooses this path. Like this. So if you want to see clearly, this is A, this is C, A to B and B to C. This is one path. A to D and D to C is another path. And directly from A to C is the another path. This is path 1. This is path 2. This is path 3. Path 1, AB plus BC. Path 2, AD plus DC. Path 3, directly AC. No turnings. In our common sense, we can say that the way from A to C is the shortcut to reach the destination. But 3 students followed the 3 different paths. Let us write the values. A to B is some 8 centimeters. B to C is 8 centimeters or 8 meters, we can say. B to C is some 6 meters. It occupied the shape of a rectangle. That's why A to D also 6 meters and D to C also 8 meters. If you want to find out the distance traveled by the body, this path 1 and path 2 are the examples of distance. So AB 8, BC 6, 14 meters. Again the path 2, AD plus DC 6 plus 8 meters, it is nothing but 14 meters. So what about the path 3, AC, this one? So if you consider this ABC is a right angle triangle and ADC is also a right angle triangle, AC is the common hypotenuse to the both triangles. So if you find the length of this hypotenuse, that will be the distance from A to C, which gives the shortcut or the displacement of the body. For this purpose, we should use the Pythagoras theorem. So from Pythagoras theorem, hypotenuse square is equal to side square plus side square. So what is this hypotenuse? AC square is equal to, if you see the triangle ABC, it is AB square plus BC square. In another way, for the another path, hypotenuse square is equal to side square plus side square. Again AC is the common. Side square plus side square means AD square plus DC square. As we know the measurements of these, what is AB? 8 square, 8 meter square. BC 6 square. Here also it is 6 square plus 8 square. 8 square 64, 6 square 36 is equal to AC square. So here also AC square is equal to 36 plus 64. Anyway, we will get AC square is equal to 100 meters. This AC square is also equal to 100 meters. AC square is 100 meters. What about AC? Therefore, AC is equal to square root of 100, nothing but 10 meters. So this A to C is 10 meters. See, AB plus BC, nothing but the distance covered by the body is 14, as well as AD plus DC, distance covered by the body is also 14, but the shortcut from A to C is simply 10, means it is less than 4 meters of the remaining paths which are representing the distance covered by the body. Now we can say that this AC is the shortcut, and we have proved this mathematically by using the Pythagoras theorem. Like this, we can separate, or we can show the differences between distance and displacement. The next physical quantity is speed of the body. Yeah, this speed is related to the distance covered by the body. So it is defined as the distance covered by a body in unit time is called its speed. So the symbol, so speed is equal to distance by time. So the symbol of the speed is, let us say, v, distance covered by is x, time is t. Its SI unit is SI unit of distance is meters, SI unit of time is seconds, therefore it is meter per second or meter second inverse, where m is equal to meter, s is equal to second. So while you are expressing the units, it is we are expressing with the symbols of the units, no need of writing the whole spelling. So what about the dimensional formula of this physical quantity? So an intermediate or it is +1 or +2 for to find the dimensional quantity is very, very important. So dimensional formula, the symbol of the dimensional formula means we should keep the prescribed physical quantity in brackets. So it is equal to, x means distance, the symbol of the distance, dimensional symbol of the distance is L, the dimensional symbol of the time is capital T. Therefore it is L t power minus 1 over R mass power 0 L power 1 t power minus 1. So what we can understand, speed is directly proportional to distance, where distance is a scalar quantity. Like that, speed is also a scalar quantity. Speed is a scalar quantity. So the speed of the body it may be positive, may be negative or 0. What is the reason? The speed is equal to distance by time. So distance may be positive, it is always a positive one because time is also a positive scale. So it is very difficult to assume the negative scale of the time, negative gradient of the time. So time is a positive constant. So this distance may vary from positive or negative or 0. If time taken is infinite, then the speed will become 0 because something by infinity is 0. This is one of the important point to describe the nature of the speed. So its SI unit is meter per second as well as the CGS unit is centimeter per second. This is one of the important point for the speed. So if you go to the velocity, where speed is dependent on distance and time, but velocity is dependent on displacement and time. If you phrase a sentence for this equation, velocity of a body is called as, it is defined as the rate of change in displacement. Rate of means we should divide the physical quantity with the time. So rate of change in displacement means displacement by time. Whether it is distance or displacement, they both are measured in the same scale or same dimensions. That's why symbol of the velocity is V. Its unit is meter per second or meter second inverse. This unit is a SI system of unit. So if this is the case, the same units are available for the both physical quantities and same dimensional formula also available. So the dimensional formula of the velocity is again m power 0, L power 1 and t power minus 1. So like this we can see the comparisons and differences between the speed and velocity. So the next one is uniform speed. This uniform speed is related to uniform motion. Yes. Uniform motion means, let us take a body which is at a position A. If this body is moving in a straight path, so it has reached a destination point called D, where A is initial position, D is final position. It has crossed over the two positions B and C in the path. So as we know that A to B is 100 meters, B to C is again 100 meters and C to D is 100 meters. Total distance is 300 meters. But if you see the interval range, means if I want to find out the speed of the body, with how much speed the body has from A to B and B to C and as well as C to D. Let us suppose this 100 meters distance from A to B, the body has covered in 10 seconds. Again from B to C, same scale, 10 seconds. C to D also same scale, 10 seconds. Means, if you want to find out the speed of the body between A to B or B to C or C to D, if you take any time, any interval or any interval positions, speed, distance by time. Distance is 100 meters, time is 10 seconds. So anyway, we will get 10 meters per second. A to B, it has covered with 10 meters per second speed. B to C, it has covered with the same speed. C to D also, it has covered with the same speed. If you see the total journey from A to D, it is 300 meters by 30 seconds. Again, you will get the 10 meters per second for total journey. So with this explanation, what we can understand is between any intervals or any positions, if the body is covering the same distance with same time, so this body is said to be executing the uniform motion. The physical or the correct definition for this uniform motion is, if a body is covering equal distances in equal intervals of time, then it is said to be executing uniform motion. In uniform motion, whether a body is executing a uniform motion, its speed or velocity is constant. This constant speed, in other words, it is called as uniform speed. So if a body is covering the equal distances in equal intervals of time, then it is said to be executing uniform motion. Between A to B and B to C and C to D, at each and every point, let us take B and C, if we find the speed at a given particular time or at a given particular time interval is called instantaneous speed. So instantaneous speed is defined as the speed of the body at a given particular time. Means right now we will say usually. So instantaneous speed, let us take it is a 10 seconds time to cover the 100 meters. At 9th second or at 90th meter point, what is the speed of the body? That is said to be instantaneous speed. What about the average speed? Average speed means total distance by total time. If the instantaneous speed and average speed is same for a body, then we can say the body is executing uniform motion. So the average speed means total distance by total time. Total distance covered all divided by total time taken. Let us say the total distance covered is capital X. Total time taken is capital T. So the average speed means S bar or V bar. Means it is a mean speed. So we are not at all calculating the internal disturbances from initial position to final position. Whatever may be the disturbances in the middle, we are just calculating the time at the starting point and time at the destination point. That's why this average speed value may change. Suppose if a bus has started from one point, it has reached to another point. In the middle, for 15 minutes to half an hour, the bus was stopped to many other reasons. Let us suppose. If this was happened, we are including or we are adding this 15 meters to its journey. We are not at all removing this 15 minutes time in the total time taken. We are adding also. Means for an observer who is waiting for the bus or waiting for this train at the destination point, for him it is late only. So like that it is crossed over the time. So that's why average speed value may change. So this is average speed. What about the instantaneous speed? Instantaneous speed means the speed of the body at a given particular time. So we can write this one as delta x by delta t. Means if a body is traveling from point to point, we will take a particular position in the middle. While the body is crossing that position, at that time, what is the speed of the body? That is said to be instantaneous. Instantaneous current. Means right now, what is the velocity? It may vary to the average velocity. It may change with the average velocity or it may change with the total velocity also. So that is the instantaneous velocity. So these all things are explained. This is the theoretical wise, but graphs are very, very important to understand this concept. Now we will see some of the graphs to understand this uniform and non-uniform motions. So the graphs for the uniform motion, it will be like this. So there are many rules to draw a graph between two physical quantities. Let us suppose velocity is equal to displacement by time. We should compare this one with tan theta is equal to y by x. Suppose this is the graph, this is theta. Tan theta, opposite side by adjacent side. This opposite side is parallel to the y-axis, that's why it is y, this is x. So, numerator in a formula, suppose if a formula is some y by x or x by y, like this, numerator should be taken on y-axis. Denominator should be taken on x-axis. So like this, if you want to plot a graph for uniform speed or non-uniform speed, this is the graph. X-axis, y-axis. On x-axis we should take time. That's why it is time. Symbol is t, unit is second. On y-axis we should take displacement. So that's why it is displacement. The symbol of the displacement is s. Its unit is meter. This is the rough graph the modal graph to find the uniform or non-uniform. So what is the meaning of uniform motion? Body is covering equal distances and equal intervals of time. That means you will get a graph which is straight, passes through horizon. Means a straight slope, pass through horizon or passes through horizon. This type of graph we will get for uniform motion of a body. Uniform motion or speed. So for non-uniform motion means the body is not covering equal distances. So maybe it will cover the equal distances with unequal intervals of time. So we should keep the time is fixed, okay, or we should keep the distance is fixed. So for non-uniform motion, no need of the straight slope because it is unequal distances in equal intervals of time. That's why maybe like this also. Like this, a zigzag path. So again it is T, this is displacement, yes. This is in seconds, this is in meters, this for non-uniform. Motion. So like this we can plot the graphs to understand the nature. Graphs, the shape of the graph explains the nature of the body, whether it is moving or not. So if a body starts with zero velocity to be continued in uniform motion, the previous graph is showing. But if the body is starting with some initial velocity, same it is x, y, here it is meters, here it is seconds, here it is distance, displacement or distance, here it is time. So in this case, if the body has started with some velocity, then like this. If the velocity is 0, from horizon. If the velocity is not 0, from any other point. So like this we can understand the uniform motion or non-uniform motion. Here we are discussing one problem which to find out the average velocity and average speed of the car. The description of the problem is like this. A car is moving along a straight line, say OP shown in the figure, O to P. So it moves from O to P in 18 seconds and then returns from P to Q in 6 seconds. What are the average velocity and average speed of the car in going from O to P and from O to P and back to Q? So if this is the discussion, yes sir, O to P took 18 seconds, O to P, and from P to Q took 6 seconds. Total time taken is 24 seconds. So we should find out the average velocity and average speed in two cases. So we will take the first case, O to P. So what is the average velocity, total displacement by total time? Total displacement by total time. O to P. O is at 0th point, P is at 360th point. Total displacement is 360 meters. Total time O to P is 18 seconds. So 18, 360, 20 times, it will be 20 meters per second. Same like average speed also, total distance by total time. Total distance by total time. Yeah, the total distance is again 360 meters. Total time is 18 seconds. So it will be again 20 meters per second. But if you choose the second case, these values are going to change. But in the next case, we should find out the average speed and velocity for O to P, then from P to Q. So O to P, then P to Q. So what is the average velocity? Total displacement by total time. So the total displacement from O to P and P to Q is, O to P is 360, P to Q is 120. Displacement means it is dependent on the sign and direction. So that's why it is 360 minus 120 meters by the time taken is 18 plus 6, 24. So it is 240 meters by 24 seconds. That is equal to 10 meters per second. That is the average velocity. What about the average speed? It is total distance by total time. Total distance, yes, it is O to P plus P to Q, 480, 360 plus 120 meters by 24 seconds. 360 plus 120, 480 by 24, it is 20 meters per second. So like this we can see the differences between the average speed and average velocity with respect to unidirection and multi-direction. The next concept is acceleration. Yeah. For most of the two-wheeler motor vehicles, there is a part called accelerator. The accelerator is useful to increase the speed of the vehicle or as well as decrease also. Means accelerator helps to change the velocity or speed of the vehicle with respect to the given situation. So acceleration means it is simply related to the accelerator, how the accelerator can change the velocity of the vehicle. So acceleration is nothing but the change in velocity by time. So this is the position of the body, initial position, as the body moving to a destination point. We know that in the beginning, velocity or speed of the vehicle is almost very lower than or less than the 20 kilometers per hour. Means very less velocity we will start the body. Zero is impossible. So anyway, the starting is some 20-30. As the body keeps on moving, we will shift the gears. As the gears are shifting, we can increase the speed of the body also. To decrease the body, we will again shift the gears and we will apply the neutral. So like that, let us say the velocity at the initial position is V1 or U. So while it is approaching a final position or nothing but the destination, its velocity increases to V2 or V. So from this, the change in this velocity occurred in a time t. So the definition of the acceleration is the rate of change in velocity. The rate of change in velocity of a body is called acceleration. The symbol of the acceleration is small a. In physics, the symbols has usual meanings. So where capital A is ampere and area, like that. So the rate of change in velocity is called acceleration. So acceleration is equal to final velocity minus initial velocity whole divided by time. So final velocity minus initial velocity by time. So what we can understand is the final velocity symbol is v, initial velocity symbol is u by t. From this we can derive the first kinematic equation of motion also. For at is equal to v minus u, therefore v is equal to u plus at. So what are the dimensions of this acceleration? Unit, so SI unit is its velocity by time. Means change in velocity is nothing but the velocity component. So velocity by time. Velocity we know that meter per second. Time again c. That's why it is meter per second square, or we can write meter second power minus 2. So what about the dimensions of the acceleration? Dimensional formula of the acceleration. We know the dimensional formula of the velocity is L by t. By time means t. Therefore it is L by t square or L t power minus 2. To find the clarity means to involve the all physical quantities, it will be m power 0, L power 1, t power minus 2. Acceleration has 0th dimensions in mass, 1 dimension in length, minus 2 dimensions in time. This is acceleration. But with respect to the given situation, this acceleration may vary to positive scale or negative scale.